Okay, I'm gonna do a little overview here of working with continuous distributions and measures of central tendency, or what Triola calls measures of center and spread. And so actually, let me talk about that for a second. Triola calls the mean, the median, and the mode the measures of center. And that's fine. That's a different term than I originally learned, and what I originally learned was measures. Oops, I'll fix that in a second. Central oops. Here's where my spelling comes in. Tendency. Okay. His term is a little bit shorter. That's kind of nice. But measures of central tendency, I think I like it a little bit better because it tells you that what we're talking about is the spread of these observations of cases, or observations, or people in a survey, or students in a classroom within this distribution. And so the central tendency of the distribution, are described by the mean, the median, and the mode. And you know that when the distribution is normal, those are all three the same thing. When the distribution is skewed, they can be different. But they're different measures of saying, where does this distribution tend to be centered? What numbers does it tend to be centered around? But another way to say that is just measures of center, and that's fine. But that's how to remember these three important things: the mean, median, and the mode. They're measures of central tendency, or measures of center. I've already set up this spreadsheet just so I didn't have to walk through the steps of doing it while I explain it to you, or at least I've set up most of it. And I'm going to work through some of the formulas in Chapter 3. Let me show you what I've done here just to set up this spreadsheet. I created a column of 15 random numbers here, and actually used a neat Excel formula for that. It's called rand between. You can see it up here, and you put in the number you want as the lowest possible number and the highest. So I did rand between 0 and 100, and then I just copied that formula down across all the cells. So you'll see each cell has that formula in it, and what it creates is a column of random numbers within that range. The trick with these, if you ever have to do something like create a random sample or something, and you use this function, you'll notice that every time I go into another cell and do something, like here I'm just going into the cell and hitting enter, so it may actually be keyed to hitting enter. No, it's not that. You actually have to go into the cell and do something. Excel will recalculate that rand between formula. So every time I do something here, you'll see that flash in that column A. Don't pay attention to that. What I did was, after the first time I did that, I copied and pasted the values that were there over in column B, which I call X fixed. So the fixed values, they're not going to change every time. So this is the column we're going to deal with. So I'll actually highlight this. Oops. Excel got a little ahead of me. And this guy, we can just ignore for a minute. Okay. And I also took that same column and I made a column of sorted values here, which I'll talk about in a second. But let's go, if you have your book, go to page 82 where he talks about the mean, and we'll go through that formula first, because I want to show you how you can do this in Excel, both doing all of the steps, like as if you were doing a hand calculation, and then a shortcut. So we know that the formula for the mean is to sum the observations. In this case we have 15 observations, and then divide by the number of observations that we have, which in this case, like I said, is 15. Real easy to do. But if we're going to use this format like we've been doing for Excel, let's do it here too. So here's the first thing we need. We need the numerator, which is the sum of the observations. And to do that, I use the sum formula. You just type in the word SUM, sum, and then the range of values that you want Excel to sum across. And this little colon here tells Excel through, so B22 through B16. So remember, the first first column, or the first row rather, is a header row, title. So we have 15 values, but they go through B16. That gives me that number right away. The number of observations, there's probably a way to count those, but in this case we just know it's 15 because that's given in the problem, and we can count this up. So I entered 15 there. And then so the solution is really simple, just F4 divided by F5. And again, I'm highlighting it here, but you can always look up here when I highlight a cell if I don't actually click into it. F4 divided by F5, because we're in the F column. And again, if I didn't like this, I could format the cells to just have 2 decimal places. That's a little bit nicer. Or maybe no decimal places, decided depending on what your purpose you need it for. Well, let's see. So that's great for learning how to do the mean, but what if I'm doing a more complex problem that just asks for the mean, and I don't need to show all the steps or go through all the steps to learn it? Excel has a formula for that. It's not called mean, it's called average. And you type it in just like regular formula, equals average, and then with the range of values that you want to average across. Now there's some point and click ways to do this. I'm not sure, I know if you want to sum, that's a really common one. You can go up here, yeah, you could do sum, average, count, you can count numbers, min, max, and more functions. So this might be a neat way if you want to learn about functions to go up here and find this. And I know a lot of people use the sum thing. I think you can even highlight and maybe right click in sum, copy, format cells. Well, I don't see it right off, maybe down here. Anyway, I've seen people do this really quickly with point and clicks, but usually when I'm using Excel, I'm doing multi-problem steps, or multi-step problems rather, and I want to just type in the formulas so I have it all there, so I don't do that kind of stuff. So let's see. So we were talking about the shortcut for average. Well, what are the other measures of central tendency? We've got a median, right? So this one's a little bit different. There's 2 ways you do the median, and it depends on whether you have an even or odd number of cases. So the median is the next example. The bottom of page 82 goes on to page 83. If you have an odd number, you just arrange the values in order and pick the middle one. That's real easy. And you see the median, the mean is literally a calculated average. The median you can always think of as sort of like the tipping point of the distribution. So it's literally that middle point. And the way I always remember this one is that think of the median in a freeway. You've got lanes on one side and you've got lanes on the other side of the median, and for the most part you've got the same number of lanes on one side. If it's a big freeway like here in Los Angeles, you might have 5-6 lanes on one side, 5-6 lanes on the other side, and so that median is right in the middle. That's always the middlemost number. Whereas the mean can be sort of anywhere in the distribution. Remember, if it's skewed and you calculate the mean, it's going to be way out in a tail of the distribution, and that's why medians are better for skewed distributions. But since that median is not something we calculate per se, it's one specific number, it's real easy to do if you have an odd number of distributions, or odd number of observations. But we don't this time. We have, let's see, or rather we do, we have 16, no, we have 15, right? So, oops. So we could just go 1, 2, 3, 4, 5, 6, 7, right? 8. And on the other side of that, if we count it up from the other side, let's do it this way. 1, 2, 3, 4, 5, 6, 7, 8. 8's the middlemost one. That's our guy. 61 is the median in this case because we have an odd number. If you have an even number, it's in some ways a little bit easier. You take the middle 2 values and you just average them. So if, for example, say we didn't have this last value and we just had up to 96. So now we've got, instead of 15, we've got 14 values. 1, 2, 3, 4, 5, 6, 7. That would be one of the middle values. 1, 2, average again, so averages, you just add up the total number of observations divided by the number of observations, and in this case just 2 because we're averaging the 2 middle values. So C8, which is 57, plus C9, which is 61, divided by 2, which is 59. And that's a case where the median isn't actually a number in the distribution, it's right in between those two. But it still it represents the literal center of the data set, the balance point. Okay, now what's this 61 up here that I didn't actually calculate? Well, Excel's got our back, and it's got a formula here, median. So if you wanted to calculate the median for our distribution here, without going through all the steps of sorting it like I already did and counting from either end and all that, you can just do median B2 through B16 to get 61. And for this one, I haven't tried this yet, but I assume it's going to be the same thing. Actually, I'll do a little shortcut here. Copy this. Oops, B2 through B15 now. Yeah. So again, if we don't want to do all the counting up and everything, we can just tell it to calculate the median of a range, and it'll do that. Okay, now what about the mode? Well, the mode is kind of neat. Again, remember, if this is a normal distribution, then the mean, the median, and the mode are the same value. We're already seeing that that's not true, so this probably isn't a normal distribution. The mode is the most frequently occurring score, and so when you think of that typical bell-shaped curve of a normal distribution, the mode is that point that occurs most frequently, that score that is at the peak of that bell. And in statistical theory and what you learn in this class, we're mostly dealing with those nice, even symmetrical bell-shaped distributions, and in reality you can have distributions with different shapes where they would have multiple modes, different peaks, if you think of those as kind of like a hill or a mountain. But anyway, you can also have distributions without any mode, and so and that's what we've got here. If you go through these values one by one, there's no one single most frequently occurring value. If we had another 96 or another 88 or something, we could say that we've got a mode, but we don't really have a mode in this case. And there's nothing wrong with that. That's just the reality of the distribution. No fill. Okay. So when we typed in mode, B2 through B16, Excel told us NA. There's no mode in this distribution.